the last sessions, we did exponents. We did basically factorizing, simplifying, cross-cancelling out, and remember you can't cancel across a plus or a minus sign. Those indicate what? Factorize. Right. Now we're going to do equations where we're going to be using all of the above skills or the previous sessions work in solving for x, right? We're going to find out what x is in an exponential equation. Now, let's just make sure that we're on the same page. Exponential equation. Okay? An exponential equation means that it has got something, a power, okay? The power could be x or the power could be a number. But an exponential equation has something, okay? Something in the exponent place, okay? Which means over there, all right? There's something up there. That's an exponential equation. What do they look like? Well, by now, I mean, you've obviously seen them, but they look like this, right? Here's an example of it, not that one. 9 to the power of x minus 1 is equal to, or divided by 3 to the power of x, okay, plus 1. Right? This is an example we're going to do. All right? Well, what did we say? Step 1 was always prime factors. You'll see it's the same. Step 1, prime factor. Well, 3 I can write as 3 squared x minus 1. Whoops, sorry, it equals 26. Over 3 to the x plus 1 equals 26. Now, I haven't written 26 as a prime factor yet, okay? Because I know how this is going to transpire, but in essence, you could if you wish, okay? But often, it's just leave the right-hand side if it's not involved, right, at this stage. Then, what was the next was step 2. Let's just recap. Step 2 was remove brackets. So let's do that. 3 to the power of 2x minus 1 over 3 to the power of x plus 1 equals 26. Step 3 was we've got a minus and a plus sign. Factorize, right? Was factorize. Now, I'm hoping you remember to the power of, I'm going to write it, 2x. What does this tell me to do? It tells me look out for a quadratic form type. It's saying that that is the same as 3 to the x squared. So therefore, rearrange it as 3 to the power of x all squared minus 1 over 3 to the power of x plus 1 equals 26. What happens next? Factorize. Okay? What is that? It's difference of two squares. Something squared minus something else squared. It happens to be 1. How does it break down? It breaks down the square root of the front, which is 3 to the power of x minus 1 and 3 to the power of x plus 1 over 3 to the power of x plus 1 equals 26, right? Here's a hint. Very often, the factor that you see, the item you see underneath is one of the factors. Because I'm going to take out my cancelling out pen, that whole thing cancels with that because I can put a bracket there, right? Which then leaves us with what? 3 to the power of x minus 1 equals 26. Therefore, 3 to the power of x is equal to 27 because I take that over to plus 1. Prime factors, 3 to the power of 3. Therefore, x is equal to 3. Right? So, hold on. It's the same steps. Right? Let's have a look at a different example. Right? It's the same steps. Let's just go through this one. 27 to the power of x minus 2. 27 to the power of x minus 2 is equal to 81 to the power of 2x plus 1. Okay? Right, what happens now? Okay? Okie dokes, let's have a look. 27 to the power of x, prime factors. 3 to the power of 3. X minus 2 equals 3 to the power of 4. Remember, use your calculator. Try with your calculator, okay? That's the first step to go with it. All right? So that's 3 to the power of 4, all to the power of 2x plus 1. Right. What do I do next? Well, I say, okie dokes, then remove brackets. 3 to the power of 3x minus 6. Remember, that's there. That's 3 to the power of 3, x minus 2. What must we remember? You must remember in every case that multiplies by everything. So that's why it's 3 to the 3x minus 6 is equal to 3 to the 8x plus 4. Right? Now, let's just add into this. Remember, we had step 1, okay, prime factors. Step 2, remove brackets. Step 3, if we see a plus or minus sign, factorize. Right? Then step 4 is our target in this. We are targeting to what? What's the target we're after? We want the bases to be the same. Bases to be the same. That's what we're after. The bases to be the same. Right? So here I've got my base is a 3 on the left and a 3 on the right. Once the base is the same, what do? Drop the base, right? So step 4, step 5 is drop the base if the bases are the same. Therefore, 3x minus 6 is equal to 8x plus 4. Take that over, you got 3x minus 8x is equal to 10. That's minus 5x is equal to 10. Therefore, x is minus 2, right? Straightforward. So what do? We do exactly what we did before. The only difference over here now is that we've got another step. Can you see it? That step is where we get the bases the same on each side, all right? And those of you who will ask, well, what if they're not? Then they would do something called logs, which we're going to do in grade 12, okay? So don't worry about it. We'll get to that. In your case, they're always going to be the same. Okay, let's just move along here. Add a page, all right? Okay, let's now have a look and say, here's another example. 125 to the power of y minus 2 is equal to 25 to the power of 2y plus 1. Okay, let's solve. Step 1, okay, we need to prime factor. That's 5 to the power of 3, and y minus 2 is equal to 5 to the power of 2, 2y plus 1. Next step, remove brackets. That's, I'm already ahead of myself. 5 to the 3y minus 6 is equal to 5 to the 4y plus 2. Okay? So, what do? Bases are the same, so I can drop the base. Therefore, 3y minus 6 is equal to 4y plus 2. And therefore, I solve for y. I say 3y minus 4y is equal to 2 plus 6. And I end up with y equal to minus 8. And then if they say, and check your answer. What do? How do we always check to see if we're right? We have solved for x. So you'll take the value of x that you've got, you'll go and put it in on the left-hand side, and you will put it in on the right-hand side and see if they are equal. If they are equal, you've got the answer. If they are not equal, there's either a mistake in the calculations, or likely in this case, or it's not a solution to the problem, which is very much the case when we come to surd equations, okay? But generally speaking, you're going to have solutions that come out of these. Right? So yes, let's just continue with one or two of these, all right? Okay, solve for x. Now let's have a look at something that looks like this, shall we? All right, something slightly different. Okay, I'd suggest you actually take this one down and do it with me, step by step, so that you've got it as a reference, right? They say solve for x, and they've given us this equation. 3 to the power of 2x minus 2 times 3 to the power of x plus 1 equals 27. Right, step 1, it's exponential equations. Therefore, step 1 is PF, prime factors. 3 is already a prime factor. That's a prime factor. This is then going to be here is going to be 3 to the power of 3, isn't it? Okay. Step 2 is what? Was remove the brackets. Well, in this case, we don't have brackets. Okay. Step 3, okay, we've removed the brackets. Then it would be split. Right? Can you remember this? So I say, okay, you are 3 to the 2x minus 2 times. That's the only one I need to split. Right? So far, so good. Okay, I've done what I asked. Okay, now, are there pluses and minuses? Factorize. Why? There's a plus and minuses in the equation, right? So we need to factorize. Now, what is the giveaway here? Okay, the giveaway is to notice once again, we've got a 2x. Look for this something to the power of 2x. Let us remember, we rewrite 3 to the power of 2x as 3 to the power of x squared minus, let's look at this. Hang on, that's 2 times 3. So I can actually work that out as 6 times 3 to the power of x equals 3 to the power of 3. All right, I've just done some manipulation. Factorize. What does this look like? All right, what does it look like? Something squared minus something times there. It looks like a trinomial. Just to recognize it, whenever you've got a 2x, you write it like that. And whenever there's a 2x and a 3x, 3 to the power of x, in the same equation, it is a trinomial. All right? And how do we solve for said trinomial? Well, there's two ways. First of all, you can do it straight off and say that's 3 to the power of x. Okay? And, oh, hang on. Whoa. What's the problem? What haven't I done? I've broken a rule. What must I do? I must bring the 27 to the other side, right? It must look like a trinomial. Okay? Because this is my, let me just do it in a different color. Let's just look at it like this, blue. This is x squared minus 6 times x minus 27 must be 0. Remember? That's what it is. My coefficient of x squared is 1. All right? Okay, now let's go back and then let's solve it. So therefore we say, okay, it's going to be x is going to be in the brackets here, which is 3 to the x. Okay? And 3 to the x, oops, I've got 3x there. 3 to the power of x, okay? Equals 0, right? Now, what's my target number? My target number is a 6, isn't it? From factorizing a trinomials, all right? So I have to find the factors of 27. So let's go and have a look for the factors of 27. 27 and 1, 9 and 3, all right? Pretty sure it's going to be 9 and 3 because the difference is a 6. 9, 3, all right? Plus, minus, can you see? Minus 27, okay? Or wrong way around, right? Okay? It's minus and a plus. Minus 9 times that, plus 3 times that is that. All right? What I'll do, let's multiply it out, shall we? Just to show you how that works. Let's just do this exercise. 3 to the x, what do we get? 3 to the x times 3 to the x. Minus 9 times 3 to the x plus, okay, right? What? No, it's minus, isn't it? Because it's, okay, whoops, plus 3 times 3 to the x, okay, which is that one there, and then at the bottom minus 3 times 9 is 27. Okay, what is 9 times 3 to the x? Remember, it's 9 of these, okay, minus them, plus 3 gives me minus 6 of them, okay? Therefore, that must be equal to 0, which means 3 to the power of x minus 9 must be equal to 0, or 3 to the power of x plus 3 must be equal to 0. Then change sides. 9, therefore, 3 to the power of x is equal to 3 squared. X must be equal to 2, right? X must be equal to 2. 3 to the power of x must be minus 3. No solution here. Okay, we don't have a negative on that side, right? So, or you can't find one that's going to give you a negative. There is, if you drew the graph, okay, it's all going to be above the axis. So, there's our answer. X equals to 2. You can go back and check it. What is the key thing that we need to recall out of all of this here? Is please look out for what? Okay, look out for a 2x and an x. Okay, those are important. They're going to be trinomials. All right. Let's have a look here. Okay. All right. Let's say, for example, they give us, I'm going to show you another method, the K method. Okay. Let's go back to our original equation. Is 3 to the power of x all squared. Let me just write this down. Remember, we've done that manipulation. 6 times 3 to the power of x. And I'm going to bring this over. Okay. We've recognized. But now we're unsure, okay, how to proceed. What you can see, can you see that we've got here this and this term here? It doesn't look like it, does it? Okay, that's a very poor 3 there. All right. Those two, okay, are the same. Okay. Now, in the K method, when you see two things that are the same, you say, let K equal 3 to the power of x, and replace it. K, can you see? Minus 6 times K minus 27 equals 0, which becomes K squared minus 6K minus 27. Now we solve that. All right? We can solve that, right? Okay, let me just get my pages a little bit better. Okay, we can solve that. We then say K, okay, and equals 0, K. So what do I say? Okay, now I go ahead and solve it. I say 9, 3 again, and that's a minus, that's a plus. Therefore, K equals 9, or K equals minus 3. Now I know what K is, but K is actually 3 to the power of x, isn't it? And I see I, in my haste, wrote K there. Can you see? I said let it equal 3 to the power of x, okay? Because that's common to all of it. So I can replace it with a K just to simplify it, just to make it easier to work with so that we don't have stuff in there that we can't reconcile with something else. Therefore, we say, therefore, and then we replace the K with what it actually is. All right? So therefore, 3 to the power of x is equal to 9, or 3 to the power of x is minus 3. No solution, and once again, x is going to be equal to 2. 3 squared, right? Okay, how do you solve this then? I wonder if you can remember from previous. 5 to the power of 2x minus 1 is equal to 0.2. What do we do when we do that? You always go to a fraction. Yep. We always go to a fraction. So 5 to the 2x minus 1, 0.2 is 2 over, put it into a calculator, okay? It's 1 over 5. What do? What is my target here? Remember, the target is I want both sides to be a 5. This side has got a 5. This side is 1 over 5. So what must I do? I'm going to change that base. 5 to the minus 1. 5 to the minus 1 is 1 over 5, isn't it? Therefore, now I can base the same, drop the base. 2x minus 1 equals minus 1. Okay? And basically, you've got that. Okay? So what have I got? That goes over, and it becomes a plus 1, and I've got x is equal to 0. And I can back sub to check. Right? So therefore, we've got last one, okay? Last one. Let's say they give us something horrendous, okay? All right? Yep, this is the last one. Let's say they give us something horrendous like this. 7 to the power of 2x minus 49 multiplied by 3 to the power of 5x minus 59,049 equals 0. Oh my goodness. Actually, all you do is you say, but hang on, they have factorized it for me. Can you see? I have got 2 brackets here, hey? There's a bracket. I'm really not good at writing those on. And there's a bracket. Let's have a look. What do we do if this was x minus 2 and another bracket x minus 5 equals 0? We put each one equal to 0. You do exactly the same here. Why do anything different? We would then say 7 to the power of 2x minus 49 equals 0, bracket 1, and 3 to the power of 5x minus 59,049 equals 0. And then solve it normally. 7 to the power of 2x is 49, prime factor, squared, right? And therefore, 2x, drop the base, now they're the same, 2x is equal to 1. 3 to the power of 5x equals 59,049. And no, you don't know what the exponent for that is. What do? You check on your calculator. Try 3 to the power of something. And you end up with 3 to the power of 10. Drop the base. 5x equals 10. X equals 2. Right? Use a calculator to find 3 to the power of 10 is equal to 59,049. Okay? Okay? Right. That's how you do exponential equations. Obviously, in the test and the exam prep, there's going to be many more of these. But essentially, I hope you've written down the recipe for it. That's the key to these, okay? Key to solving exponential equations is a recipe. Key to simplifying is essentially the same recipe, except you don't have to find x at the bottom, all right? So that's how we solve that. In the next one, we're going to be doing number patterns, and I will see you in that one. And good luck with the exponential equations. Do a few. Remember, change decimals to fractions. Cheers. Good luck with it.